In this video, I'll give you an introduction to exponential equations. And so the three steps that you want to start with is to take the constant terms to one side, the terms that don't have a letter. And so in this example here, I would just take the 1 across. Try get the term that has the variable, that has the letter by itself. And so I want to try and isolate just the 27 to the x in this case. And the last thing is, in exponential equations, you always want to try and get the same base so that you can, in a sense, drop the base and just be comparing the powers. And so you'll see that happening in these two brief little examples. We'll do some complex ones later. So I take the 1 across and it becomes 54. I'm going to divide it by 2, so it's 27. And in this case, I don't need to get the base any smaller because they are the same. X simply will equal 1. In this example, I would take the 486 across first, then I would divide by 2 so that I've got just the base that has the variables on one side. Then if you know this is 3 to 5, great, throw a party. If you don't, you can go 243 equals and then press shift fact and it will spit out 3 to the 5. Now that they've got the same bases, it means that x plus 2 must equal 5. So I can take it across and x just equals 3. And that's how I would approach exponential equations. There are two tough exceptions, but I'll look at that in another video. The second trick for today is to get rid of a power. You just make a power to its reciprocal, which means flipping the fraction around. And so if it was 2 over 3, you'd suddenly make it to the power of 3 over 2. But you keep the same sign. If it was to the minus 7 over 4, you'd now make it to the minus 4 over 7. Reason being so that everything can cancel out and you'll always be left with a positive x to the 1. And so here's an example. A to the negative 2 over 3 equals 4. This is all I started with, and I'm making it to the reciprocal with the same power, and that will end up cancelling completely and leaving me with a. This will end up leaving me with 2 to the negative 3, which is an eighth. Here's another example. If I had x to the 8 equals 10, to get rid of a power of 8, I'd do the reciprocal. This is like 8 over 1 if it helps you. So I make it to the 1 over 8. And so 10 would also have to be to the power of 1 over 8. If the power is even, then your answer must always be plus minus. And so whatever this is as a number, that will be your final answer. And the last example to show you with equations, this is a lovely, lovely, lovely little trick. In exponential equations, if it equals 1, you can change it to have the same base to the power of 0. And so if I had p to the x squared minus 4 equals 1, then the best option of having the same base would be p, and all I do is I make it to 0, because anything to 0 would be back to being 1. And by doing that little step, I've now can say that the power x squared minus 4 must equal the other side's power, and from there you can factorize it and you can get your two answers. So if you ever see a question that equals 1, remember this trick, and knowing that I can come back to it and make it whatever the base was on this side. If this was 5 to the x squared minus 4, then I would make this 5 to the 0. And that's how you solve these types of equations with exponents. If you found this helpful, please like this video, subscribe to our channel, and share it with your friends. Thanks.